Well, greetings out there in YouTube land, and welcome to today's new video, which will feature the contents of this box. And to be honest with you, I have no idea what's in there. So let's get it open and see what today's challenge will be. As I'm unpacking it, I wanted to congratulate the person who wrapped it up. Very unusual method. The box body here is completely wraps around a solid double weight cardboard with a removable end, and the chassis is safely nestled inside. This is a really nice packing job, and the best part for me is I'll get to reuse it when I send the amp back to the owner. Another pleasant surprise, the amp owner included a couple packs of kitty treats for Jack and Casey and Ollie. And I know, since they actually do most of the work around here, that they're going to work extra hard on whatever the contents are of this box. Let me take a second here to address all the budding amp techs out there. When you accept shipped amps, and they come in really lousy boxes, all torn to pieces and poorly packaged, prepare to spend about as much time repacking and return shipping that amp as you spend fixing it. Okay, it's sort of a hidden expense that you might not expect, but believe me, it's a considerable one. Okay, if you spend an hour or two finding a box, tape, packing the amp all up, another 30 or 40 minutes taking that box to FedEx, believe me, it's something you need to factor in on the price that you charge for shipped amp repairs. Well, here's the chassis that was lurking in the box, and it is a great big heavy one in beautiful clean condition. It is a Noble Symphonic Model 990. Anyone looking at this schematic will immediately recognize the symbols for varistors and will know that this is actually a Magnatone amplifier, and I believe it's a 280A. Okay, the 280 used a rather unusual output tube called a 6CZ5, whereas the 280A used the 6973 output tube. And as I looked in at the tubes, it appears that we have some 6973s, so I'm guessing that this then is actually a Magnatone 280A, which was the absolute top of the mark around the late 1950s. It was the best amp that Magnatone made. So this will not only be an honor to work on, but looking at how complex the circuit is, I imagine it's going to be somewhat of a challenge. Okay, but that's always the best kind, as long as the challenge is overcome and ends up with a good result. I don't have a note from the owner telling me what specific things to look for, so I'll have to contact them. I will say this much: when you're sending tubes and you're numbering them to match a tube chart like that, don't put the number on a piece of tape that covers over the Amperex logo, because when I pull this tape off, almost all of that logo is going to come with it. If you're going to label them on the packing material on the outside here, not on tape on the tube, okay? Because those type of trademarks are really precious and we really need to preserve. It looks like the owner also sent some really nice pin-up photos here for Jack and Casey and Ollie of the owner's kitty. Actually, two separate kitties. Okay, so we really appreciate the photographs of the furry little rascals, and also some pictures of the part of the amp that was not sent, showing the super nice, I believe, Oxford speakers, the top of the chassis with all the tubes installed. I don't know if he has the tube shields or not. I'll have to check. It's good if you got them to use them. And also a picture here showing the speaker complement with the two 5-inch tweeters up above. Now this is a true stereo amp in that the output is completely separate. It can be separated from this pair of speakers and this pair of speakers right here, kind of a woofer, mid-range, and tweeter. So it is the Ultra Deluxe. According to Magnatone, it was suitable for just about every instrument you could think of, including accordion, which is who I think Noble badged these for. The only thing I see about it that sends some shivers up my spine is this hideous black tape that has been put on here, I guess to show the ideal settings for the knobs. Boy, there must be a better way to do it. And I've seen this on other Magnatones, and to be honest with you, I think I bid on this amp about a year or year and a half ago on eBay, because I remember thinking it was a Magnatone 280, and a lot of people don't put the name Noble together with Magnatone, so sometimes you can get a pretty good deal on these. But I remember that hideous black tape, and wondering if there was going to be any good way to remove the sort of the vestiges of it, because God, what an eyesore, huh? But otherwise, just flawless and gorgeous. Plus, the extra knob came along in the box with the tubes. So let me go in and contact the owner, see what it is about this that's not ideal in its performance, and then we can get started. I couldn't resist flipping the chassis over, and as you can see, this is a very densely populated complex circuit with all sorts of unusual, rather large capacitors here, all of them strapped with resistors to distribute the voltage evenly amongst them. All Fender fans will recognize the blue molded capacitors, which have a really good reputation. We see the Selenium rectifier right here with a broken plate, which can't be good, but it gives us a chance to snort some of that selenium. All in all, it's, as I said, complex, but unmolested, okay, and you couldn't ask for better condition. I don't think this amp's ever been worked on. Doesn't appear to be. If so, they were very stealthy about it. Alrighty, let me go find out what's wrong with it. Well, I can see why one of the knobs was not installed on the front of the control panel, because the little set screw's been lost. Let me dig through my parts drawer here for set screws and see what I can find. Well, fortunately, I was able to find a perfect set screw for the knob. So let's reinstall it back here on the speaker selection pot post. Well, while we're waiting to hear back from the owner about exactly what he wants done with this amp, let's replace the old original two-prong power cord. Let's remove the death cap, and let's replace the Selenium rectifier. Well, we've got our 3-wire power cord all installed with the black hot wire going first to the on-off switch, then to the fuse, and then into the primary of the power transformer. The white neutral wire goes here to this newly installed terminal strip and to the other primary wire from the transformer, and the green chassis grounding wire is soldered here to a soldered lug on the chassis. Now let's focus on this broken Selenium rectifier. I have a feeling that happened in transport. But regardless, it has to go. So here is the Selenium rectifier on the schematic. Using a diode symbol, you notice that the bar is toward the transformer. Well, here is the output from the transformer. So the band corresponds to the bar. Okay, so we put it in this configuration. I've added another terminal strip to make sure nothing's loose and flopping around to make it look original. And here is the output from the that winding for our negative DC bias. We've got a resistor and we've got a filter cap here. So let's see if we've got it wired right. I've got the amp plugged into the current limiter. I flip on the switch and we see we have about negative 34 volts DC. It's always good to check that it's negative DC to be sure you haven't put the diode in backwards, because if you run positive DC to the grids of your output tubes, you will be kissing them goodbye. Okay, so it looks like everything's working just fine here. All right, I talked with the owner and asked him what his expectations were with this. He said that he really wants it to stay as original as possible and to only replace the components that had failed or were failing. So it looks like the vast majority of capacitors, resistors, and other components are going to remain intact. But he did say that one of the channels was dead, that he was getting absolutely no output, I believe from channel 2. So let's go ahead and plug in some speakers and see if that's true. Okay, I've got a nicely matched pair of vintage 12-inch Jensen speakers wired up to the cabinet speaker wires. These are the wires that are going to go to those two 12-inch and two 5-inch internal speakers in the Magnatone cabinet. I've got a 50 cycle tone here on my signal generator, so let's turn up the volume. That speaker's working fine. This one's stone dead, so it looks like what he said is exactly true. Let's start checking out all the wiring and see if we can figure out the cause. Okay, I've drawn up a really simple and rather crude diagram here of the speaker connections. See here, these are the secondaries of the two output transformers going to channel 1, hot wire, the neutral wire to ground, same here. Then we're going to send this one up to the contact here, the leaf, and the ground contact is going to go to the right internal speaker. Now the reason for that is that if you plug in an external speaker, you'll lift the leaf off of that grounding leaf, disconnect the internal speaker, and then only the external speaker will work. It's the same on both sides. So simply by plugging in your external speakers, you're disconnecting the internal speakers. But this switch right here can override that, and if you close that switch, you see that you are bypassing that ground leaf that was disconnected and closing it so that both your internal and external speakers will work. So depending on the position of that switch, this one right here, you can either have external speakers or internal speakers or both. However, with all that said, I can find nothing wrong with any of the contacts, the switch, anything. If I connect directly to the terminal, the speaker works fine. If I trust the system, the speaker does not work properly. So I'm going to have to start looking at the wiring and see if I can figure out if there's a bad contact or a wire that might be broken within its insulation. Okay, we see here that we have two output transformers. Here is the B plus going in. Here is the connection to the tube plates of the two output tubes. So there's the primary, and here is the secondary coming out. Green then will be the amplified signal, and black will be the neutral or ground wire. You see that the black comes over here and is grounded to this lug, whereas this green comes over here to the left-hand terminal. We look here at the second output transformer, same exact situation. We have B plus here. Here are the twisted leads over to the plates of the second pair of output tubes. So in this case, we have our black coming here to ground, just like we did in the first output transformer. And the second lead that comes out will be this one back here, which is green, and comes around to this terminal. So we have the output from our two output transformers coming to this terminal for this one, and this terminal for the second one. Well, after eliminating about 400 different variables, it turns out that one of the black ground wires for the channel that was dead was not properly soldered here. It was held in place, but it wasn't making good contact. Okay, so now I'm going to strip these and solder them properly to that ground lug, and I think both of our speakers are going to work just fine. It's time to see if our repairs have worked. Remember, I had to resolder the channel 2 ground wire for the speakers. The speakers are now connected to the internal or cabinet speaker wires from the amplifier circuit. We have the 50 cycle tone being piped in. Let's turn it on and see if both speakers now have equal volume. Sounds pretty equal to me. I would say that our problem is okay. I'll flip the standby switch off. You notice we're starting to get a little bit of illumination back here in the current limiter. I'm going to guess that that's normal because this is a pretty husky amp circuit, but we'll definitely keep an eye on that. Just for the fun of it, let's see how much current this thing does draw. I'm using my ammeter here. I've got the amp plugged into it and it's plugged into the current limiter. We're on power on, but also in standby mode, so we're drawing very little current here. It's just to heat up the filaments. Now when I go to full operation, I'm using what, 1.25 amps. Okay, so really that's a small draw for a amp like this with 4 output tubes, 6970. I can also equate that with that much glow in the bulb. So the fact that the bulb almost never illuminates tells me that most of the amps that I'm working on are drawing like 1 ampere or less current. So really then I don't think the draw is very significant. Before we continue, let's stop for a second and take a look at the tube set that came with this amplifier. And this really is a wonderful tube set. 12AX7s are Amperex. The rest of the tubes are either GEs or the 6973s are all a matching set of RCAs. So let's hope that these are all good tubes. Well, as predicted, both triodes of the 3 12AX7s and the 3 6CG7s all checked out just fine. Now that the amp is working, I wanted to check the plate dissipation on the 6973 output tubes. They seem rather warm to me, and sure enough, as you can see, I have measured the resistance of the half windings of both of the output transformers. Remember, this is a true stereo amp. It has 2 separate output transformers. You see the voltage drop across the resistance, and then I've calculated the plate current and plate dissipation. Now the maximum for the 6973 is 12 watts. We know, since this is fixed bias, we go with 70% of that, so we should be a little below 8.4. So with that in mind, we'll see here what the plate dissipation is of our 4 output tubes. High, 11.68, a perfect match, but still way too high, over what, 3.2 watts. This one is the only one that's even close to being acceptable, and it's 1.5 over, and look at this beast. You could fry eggs on that one. So we're going to have to increase the amount of negative DC that we apply to the grids of these tubes to try to bring these values down. Now, one thing that's kind of unusual is that the amount of negative DC bias being applied to the grids right now is in agreement with the schematic. Now, all I can think of is that they didn't observe the 70% rule back in the early 60s. If the tubes were biased anywhere near acceptable of around 12 watts, and you can see They are 1168 low, and that one's a little high, but if you're going to accept 12 watts as your plate dissipation, then this is set fine. But we know from bitter experience that you've got to reduce that plate dissipation with fixed bias circuits. Okay, so I'm going to then follow the modern thinking and reduce the plate dissipation in all 4 of the output tubes. Now, we've already overhauled the negative DC bias circuit. We see here is our diode that rectifies it. We come over here, this is what distributes it, this green wire distributes it to the grids, but we see back here our 47K resistor to ground. Now what we need to do is increase its value so more of the negative DC goes to the grids and less goes to ground. Now, to adjust the bias of the output tubes, I've removed that 47K resistor to ground from the negative DC bias supply. I've replaced it with a 100K pot, which will allow me to dial in exactly the resistance needed to get the plate dissipation values under the 8.4 watt limit that we've set for them. Then once I have found what that exact resistance is, I will install a fixed bias resistor in its place. Before I continue with the biasing procedure, I wanted to mention some steps we can take when we have 4 output tubes to better balance them. We see here on the left, and as previously mentioned, that the matching as far as plate dissipation is perfect, whereas on the right side it is very imperfect. We have one tube that's operating at about 9.94 watts and the other is at 13.47, difference of around 3.5 watts. Okay, the culprit here is, it depends on how you look at it, either a tube with a rather weak cathode or a tube with a very, very strong and intact cathode. The better tube is able to produce greater plate current than the weaker tube. Now, the way to better neutralize this excessive difference is to take one of the tubes from the left. I know it hurts us to break up a perfectly matched pair, but if we take one of these tubes and pit it against the hotter tube, we'll find that the average plate dissipation over here, and when we move the weaker tube over here, that the average plate dissipation on the left will be about the same. Let's take a look then at the post-switching results and see what we think. Now we have 11.7 watts versus 9.74. That's about 2 watts difference, and on the right we have 8.34 versus 9.8, which is about 1.5 watts difference. Now, as you can see, the error on both sides is about equal, and all 4 tubes I think will work better than the gross mismatch that we had before with the perfect match versus the very, very imperfect match. I swapped the output tubes around, trying to prevent any one of them from having a really grossly elevated plate current, and I greatly increased the resistor to ground in the negative DC bias supply, and as a result I end up with these voltage drops, these plate currents, and these plate dissipation. As you can see, we're much closer to 80% of max rather than 70%. This one is just a current hog, and there's not much I can do to calm it down. This is what I'm going to live with, and probably the life expectancy of this particular tube will be a little shorter than the others. But it's the best I can do with what we've got in the circuit. Now, one thing really caught my eye when I first looked at this chassis from behind, and that is there are 4 input jacks, which is fairly typical, but one of them has an extra leaf, and that extra leaf contacts the shield or ground of the 1/4 inch input jack. Now what purpose could that possibly serve? And is this even an original input jack? Let's take a look at the schematic. And it is original. If you see here, there's the extra leaf, whereas the other three jacks don't have it. Now what is the purpose of it? Well, if we follow down here to the oscillator of the vibrato circuit, we see that there is a switch. It says instrument or foot switch. Now those of you familiar with Fender tremolos know that you have to have a foot switch installed to give ground to the tremolo circuit. Well, Magnatone went one better. Yes, the foot switch can provide that ground, but if you have this switch in the instrument position, the 1/4-inch jack can provide that ground through that extra leaf. So there's two ways then of activating the vibrato. Plug your 1/4-inch jack into this socket, or have a foot switch in the grounded position. And here you can see the white wire from that grounding leaf coming over here to your foot switch or instrument switch, which allows you to provide the ground to the vibrato circuit either by the foot switch, which is right here, or by plugging into that 1/4-inch jack. And so therefore the reality in this case really does pretty well resemble the schematic. Okay, you see there's the white wire coming down here to the switch, and here's the foot switch plug right here. You can't help but be impressed by the beautiful wiring job that was done. Notice that the polarity of all capacitors is observed. The values are upward facing you so that you don't have to unsolder them to figure out what value the capacitor is. Everything is very neat and in good geometrical alignment. Not only that, but the whole preamp section and output tube section is mounted on a rubber isolated sub-chassis to cut down on vibrational feedback to the tubes. Now those of you familiar with high watt amplifier wiring know how the military spec wiring was done in them, generally by former military technicians, and everything is geometric, right angled, and bundled. Now such is not the case here with the Magnatone, because we do get a little bit of that plate of linguine look right here, but other than the point-to-point wiring that's sort of draped between sections, this is, in my opinion, one of the best constructed amplifiers that I have ever worked on. Truly quality work for a quality instrument. For those of you wondering what varistors look like, here they are, and there's 8 of them in this circuit. They look sort of like the old dog bone resistors, but there are no markings at all anywhere on them. And I think it was sort of a proprietary secret exactly how they were achieving the vibrato effect in these amplifiers. So they bought these varistors and they are unmarked, and to this day present a great challenge for those who are trying to emulate the varistor circuit from these early Magnatone amps. Now, I'm not going to go into great detail about how the vibrato circuit works in Magnatone amps. I've already done that in a preceding video on the panoramic amp that was also made by Magnatone. I'm going to put a link in the video description so that you can refer to that video and hear the detailed description of how this vibrato circuit functions. I felt it would be redundant to put such a lengthy description in 2 almost consecutive videos, so I hope you understand and will refer to that link if you want to gain more information on how the vibrato circuit functions. I will say in conclusion that the difference between the vibrato circuit that we have here and the tremolo circuit that we're much more familiar with in other amps is that tremolo rhythmically modulates the volume of the signal. It's very much like you're turning the volume control up and down, and you get the typical tremolo effect. Vibrato, however, uses an oscillator circuit much like the tremolo does, except that that circuit interacts with the varistors to modulate rhythmically the frequency or pitch of the signal. So instead of volume modulation with tremolo, we're going to get pitch modulation with our vibrato. And I will tell you, as you will see shortly, it sounds unlike anything you probably ever heard before. You'll be able to tell immediately the difference audibly between this and what you're accustomed to in a tremolo effect, and I think you'll find this to be very interesting, especially if you've never heard it before. And I will point out the oscillator circuit in this Magnatone amp. It's going to use one triode of a 12AX7, and you see we have a 0.01, 0.01, and 0.022 oscillation loop. Here is the 12AX7, and here are the three capacitors, the 0.01, 0.01, and 0.022, securely connected between two terminal strips and connected to that triode of the 12AX7. One final observation about the circuitry. We see that we have sort of like on Fender inputs, where depending on which input jack you select, you'll have different input impedance. Therefore, if you plug into the upper jacks, you'll have high gain, and you'll have lower gain on the lower jacks. We'll see that that is the case when we go into our audio demonstration. Okay, I have installed a 3-wire power cord with proper wiring for the primary circuit. Replace the Selenium rectifier with a good stout diode and rewired the negative DC bias circuit with new components. We have altered the bias resistor so that the plate dissipation of those four 6973 output tubes are now within reasonable limits, and rearrange them so that they're sort of balanced. It's not exactly perfect. We've also solved that problem with the mysterious failure of one bank of speakers to work by reconnecting the ground wires for those speakers. I've gone through and tested the resistors and replaced several of them. I found that the capacitors all seem to be in real good shape, so I'm going to honor the owner's request to leave this just as original as I can. And let's focus on a really extraordinary audio demo for this, okay? Because it has the two separate output transformers, I'm going to connect it to two very different speakers, and then we're going to collect a stereo recording. In other words, one channel from, and it won't be these speakers, you'll see what I'm going to use, but we're going to have a left and right channel. They will be different, and I'm going to incorporate this in the video so that you have a stereo soundtrack for this video that is going to give you a difference between the two speakers, which should give you a lot of depth and complexity in the tone, or at least let's hope. Okay, so let's turn this around and get ready for our audio demonstration. Well, Ampaholics, we have a really special audio demo in store for you today. I'm going to try something really different. I'm using an SM58 microphone on a 15-inch Alnico speaker in one of my home-built amps, and we're using the 12-inch Jensen ceramic speaker over here with the SM57. We'll be recording using the two external speaker outlets, bearing in mind that each one of these will come from a channel that has its own dedicated output transformer. I'm thinking that the combination of the Alnico and the ceramic should really give us a full-bodied tone. Okay, we're going to start off here in the vibrato socket. If you recall when I discussed this, this is the one with that extra leaf that's going to turn on our vibrato. However, the first few tests that we're going to do, the vibrato is going to be turned completely off. Then we'll turn it on for a contrast. The tone controls, for a little extra clarity, I've gone to treble at about 9 o'clock here, and the bass will be at the neutral 12 o'clock position. I'm going to leave the bright switch off. Okay, and we're going to be recording two separate channels here on our Tascam 8-channel recorder. You see I have the two channels ready to go. Okay, if you're ready, Ollie and Jack are all tuned up and ready to go, so let's get started with our audio demo. Well, that's about it for this very special video on the Noble Super 990 / Magnatone 280A. I hope you've enjoyed it and that you'll stay tuned for future videos. I want to take a few seconds to thank all my Patreon patrons and PayPal contributors for keeping us on the air and advertising free. Should you like to join them, you'll find links in the video description that will help you to do so. And now for our part 2 video. I spent a couple weeks in April putting a whole new front end on the 1930 chopped and channeled Model A coupe. And I'm going to take you through that step by step so that you'll see all the procedures that were involved and see what the end product looks like. That sounds interesting? Stay tuned because here we go. Well, today we're going to begin a very challenging job. This is the front suspension on the 1930 chopped and channeled Model A coupe, and I'm going to replace the straight axle, the leaf spring, the radius rods on the side, the spindles, and the disc brake units that are on both wheels. Okay, it's going to be fairly challenging because all of the distances are going to be changed. The new front axle is a little narrower, so the tie rod will have to be shortened, and new brackets will have to be welded on the frame back here for the longer split wishbone radius arms. So I guess the first order of business is going to be to remove all of the parts that are going to be replaced. I'm also going to remove the aluminum friction shocks. I don't think there'll be room for them because the new spring is going to arch up, and probably they would interfere with it. So I'm going to remove them and see if there's another way that I can mount them. Okay, so let's get started. Step 1, of course, is to remove the tires and wheels so that we have free access to the front end. Next, let's remove those hairpin radius rods. I released the tie rod here from the steering arms on both sides, and I had to loosen the grill shell and lift it up a little bit so I could get at the nuts that hold the spring into the spring perch. So that's the next job, is to remove the spring and drop it. I also separated the brake lines from the frame so that they wouldn't be stressed when the axle and spring were dropped. Our day's work is finished. The whole front end and all the steering arms and everything have been removed. Some of the new parts have started showing up already. Let me go inside and show them to you. Here's the chrome straight axle. Absolutely gorgeous. It's like jewelry. Way too pretty to put on a car. And here are the split wishbones that are drilled for that industrial look. And they're chromed also. And now I'm going to have to wait for several more boxes of parts before we can start assembling this. Now it's time to install the new front end. First step was to weld in the holes that I drilled for the friction shocks and grind and paint the surface. Now with those holes filled in the frame and ground smooth and painted, it's time to install the transverse leaf spring. It has to be absolutely parallel to the front of the frame, and it is held in the spring perch with brand new grade 8 bolts and all the proper hardware and lock washers. Now the next job is pretty tough. I've got to use the cutoff wheel to remove the bracket for the old radius rods and then relocate it way back here wherever those split wishbone eye bolts are going to end up. Okay, I'll have to install them and then figure out where the bracket has to be. Hopefully I can salvage this bracket and just reinstall it back here. After putting some graphite lubricant on the bolts that go through the shackles, they have really nice thick nylon bushings also. This piece right here is screwed into the split wishbone. You can see the end of it here. I'm going to get an acorn nut to cover that. And I've got the hydraulic jack holding it up in place, and then at the rear I've got it tied, and that will be how I figure out exactly where to locate that rear bracket and weld it. And so this is the new drilled split wishbone radius arm, and as you can see, it tilts back at the top. That gives you your caster on your straight axle. I'm going to have to cut the bracket off and on the other side and mount that one just the same, and then we'll know exactly where the axle is going to be and exactly where that rear mounting bracket is going to be. Also, I think the wishbone would look a whole lot better if within the holes inside this area here was painted black. Then you'd just have your holes kind of set against a black background. I think it'd look a lot better. Well, we got a lot done today. We have both of the radius rods installed, other than the rear brackets, which will have to be positioned and welded. Painted black inside to emphasize the holes. The original radius rod brackets have been cut off. We've got the spring installed with new hardware, and this just gorgeous I-beam front axle. I wanted it out. The reason I went with a spring behind is to just position this forward and like it's just the featured piece here, okay? It's just, to me, that's just gorgeous sitting out there, and it's way ahead of the frame, called a suicide type front end. So that's where we're going to stop today. Tomorrow we will install and weld those brackets, and I'm trying to think. There's a bunch of other things. Oh, probably install the spindles on the ends of the straight axle. Okay, so I'll see you again tomorrow. Here the radius arm brackets have been welded to the frame, and the weld ground down, and everything painted. The heim joint here has been adjusted exactly to square the straight axle in perfect parallelism with the front of the frame, and everything's been bolted down tight. Now it's time to install the spindles on that straight axle. First off, this adapter here for the rotors had to be pressed on to the spindle shaft for the modern bearings that will be used, and then it all had to be painted, and we're going to put this onto the straight axle and then slide the kingpin in from the top, making sure that we pass through the thrust bearing right down here at the bottom, and then we're going to insert this cotter key into the straight axle tube to lock in right here and make sure that that kingpin doesn't come out when we're cruising down the interstate at 80 miles an hour. Okay, so that's our next step. Here we have the spindle installed on the end of the straight axle. There's a lot more going on than what you might imagine. You have to hone the bushings in the spindle to exactly fit with like zero clearance the kingpin. Then you have to fit the cotter to that notch in the kingpin, and when you're through, there's some resistance which will go away as you drive the car, but absolutely no play in any direction. Okay, so that's it. Also, some people like to chrome everything, and I think really that defeats the purpose. To me, there should be some contrast to the chrome here and there, and I think the black and chrome looks better than chrome and chrome. Okay, also it's cheaper. Well, that's it for the part one video of the front end replacement on the 1930 Ford Coupe. Hope you enjoyed it. I will include the part two video as the second feature in our next amp video, so please stay tuned. Thanks so much for watching.